We'll now look at section 1.5 and discuss linear equations in one variable. Let's begin with the definition. A linear equation in one variable, say the variable x, is an equation that can be transformed into the form ax plus b is equal to 0, where a and b are real numbers and a is not equal to 0. Such equations are also called first-degree equations, as x is raised to the first power. So basically, when we're talking about a linear equation, we're talking about a statement of the form ax plus b. Notice that there are no powers that are visible. If it has a squared, it's not a linear equation. If it has a third power, it's not a linear equation. A linear equation has to have as its highest exponent an understood 1. So an example might be something like 5x plus 3 is equal to 0, where the highest power in your expression is the first power. Our first example asks us to solve the following linear equation in one variable. Our equation states 4 times the quantity x plus 2 is equal to 3x minus 3 times the quantity 2x minus 1. Our first step is to use our distributive property to clear our parentheses. So in doing that, we will take this 4 and we will distribute through the x plus 2 parenthesis, and we will take this 3 and distribute through the 2x minus 1 parenthesis. So 4 times x is 4x, 4 times 2 is 8. I'm going to rewrite the plus 2 is equal to 3x minus negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. We'll now combine what we can combine on each side. The 8 and the 2 make a 10. So on the left we have 4x plus 10. The 3x minus the 6x are like terms. So those two combine to give me negative 3x plus 3. We'll then make as our goal that we want the x's on one side of the equation and the things that do not have x's on the other. So I can begin moving my terms around by adding a 3x to both sides. So I now have 7x plus 10 on the left is equal to 3 on the right. I can subtract the 10 from both sides, which gives me 7x is equal to negative 7. And then I can divide both sides by 7, which gives me as a final answer x is equal to negative 1. So that is a fairly easy linear equation with one variable that we were asked to solve. Now, we're going to look at several other examples that are maybe a little bit more difficult. Part A in this example has a decimal, and so the decimal makes it a little more difficult to deal with. We have 0.25 times the quantity x minus 3 plus 0.08 is equal to 0.15 times x. And we want to solve that expression for x. And so I'm going to begin in much the same way that we did the other problem, in that I'm going to distribute this 0.25 throughout that parenthesis. So 0.25 times x is going to be 0.25x. 0.25 times 3 is going to be 0.75. I'm going to rewrite the rest of the expression without making any other changes. We'll now combine like terms. So we have a negative 0.75, and we have a 0.08. And if we subtract those two, we're going to get a negative 0.67. Now our goal is to get the x's on one side of the expression and the numbers that do not have an x on the other side. So we'll begin by subtracting the 0.15x from both sides. And so that's going to give me 0.10x minus 0.67 is equal to 0. I will then add the 0.67 to both sides. So that's going to give me 0.10x is equal to 0.67. And then I will divide both sides by 0.10, which gives me as a final answer x is equal to 6.7. For part B of the problem, we have fractions. So we have y over 6 plus 2y minus 1 divided by 2 is equal to y plus 1 divided by 3. It is often easier to work a problem with fractions if you can find a least common denominator and use that to clear the fractions out of the expression. If I look at my denominators, I have a 6, a 2, and a 3. And so the least common denominator, if you look at multiples of these, we would have 2, 4, 6, 8, and so forth. On the 3s, we would have 3, 6, 9, 12. And on the 6s, 6, 12, 18, 24. So just looking at some multiples, I want to find the smallest thing that they have in common. And I notice that they all have a 6 in common, which tells me that if I multiply my 3 fractions by 6, that my fractions will disappear. And so that's what I'm going to do. I'm going to multiply each of these fractions by 6. So the first fraction, the 6's just cancel out, leaving me a y. On my second set of fractions, 2 goes into 2 once, 2 goes into 6 3 times, and so we have 3 times the quantity 2y minus 1. And on the last set, 3 goes into 3 once, 3 goes into 6 twice, so I have 2 times y plus 1. And so what we've done now is we've cleared the fractions out. The problem should become easier to solve. We're going to next use our distributive property to distribute the 3 through that parenthesis. So 3 times 2y is 6y. 3 times negative 1 is negative 3. We'll do the same thing over here, distributing. So we get 2y plus 2. Again, we'll combine what we can combine. We have a y and a 6y, which makes 7y minus 3. Is equal to 2y plus 2. And then we'll start moving things around so that all the y's are on one side and the things that don't have a y are on the other. So we will subtract the 2y, giving me 5y minus 3 is equal to 2. We'll then add a 3, giving me 5y is equal to 5. And then we'll divide both sides by 5, giving me a final answer of y is equal to 1. Part C of the problem, 3x minus 7 is equal to 3 times the quantity x minus 2. So again, we'll begin with our distributive property. We'll leave the left-hand side alone, 3x minus 7. We'll distribute on the right and get 3x minus 6. when we start to move our terms around, we would begin by subtracting the 3x in an effort to move it to the left-hand side. But notice when we do that, it falls out of both sides. And so we're left with -6 is equal to -7. And so the problem here is that this is not a true statement. We don't have a variable. The variable has fallen out, and what we're left with is a false statement. And so what that tells us is that there is no solution to this original problem. And so a false statement simply means no solution, and we stop with that. All right, let's look at part D. We'll begin the same way. We have 5x plus 12 on the left, and then we have 5 times the quantity x plus 3 minus 3. And so we'll begin with our distributive property on the right. So we have 5x plus 12 is equal to 5x plus 15 minus 3. And so again, when we start to move terms around, like subtracting the 5x from both sides, we'll see that it's going to fall out again. And so that's going to leave me 12 on the left. It leaves me 15 minus 3, which is also 12 on the right. And so we end up with a true statement. So what does that tell us? If it's a true statement, that tells us that there is an infinite number of solutions, that the solution set is all real numbers. And in actuality, if you look at your original statement, it's exactly the same thing on the left as what we have on the right. 5x plus 12, and then if we had simplified down here, we would have gotten 5x plus 12. So all real numbers constitute the solution set for this equation.